Now we'll talk about polynomial functions. Let n be a non-negative integer. A polynomial function is a function that can be written in the form a sub n x to the n plus dot 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 a sub 2 x to the 2 a sub 1 x to the 1, which is just x, plus a sub 0. Now all these a's are just coefficients, and then x's are the variables to the powers. So each I is a coefficient, a sub I, and a sub I x to the I is a term of a polynomial. So which of the following would be considered polynomial functions? Well, if we look at this first one, we can distribute, or we can multiply through. That's 6x to the 4th plus 4. That is a polynomial. Next one, if we distribute, that's negative x cubed plus 4x. That too is a polynomial. But this last one, 5 times the square root of x plus 2, that is not a polynomial. Because a polynomial is going to have integer, I shouldn't say even integer, non-negative integers, so either 0 or positive integer powers. So not a polynomial. So identifying the degree and leading coefficient of a polynomial. The leading coefficient is going to be that first non-zero coefficient. It could be a 1, or whatever it's going to be. Like this first one was a 6, the negative 1 for that one. And the degree would be the term with the first term with the highest term, highest power term, with the non-negative leading coefficient. So how to identify the degree and leading coefficient of a polynomial? Find the highest power of x to determine the degree function. Identify the term containing the highest power of x to find the leading term. Identify the coefficient of the leading term. So for these, identify the degree, leading term, and leading coefficient of the following polynomial functions. So they're not written in descending order necessarily. So this one, you could rewrite this as negative 4x cubed plus 2x squared equals, or plus 3, not equals 3, plus 3. And our leading term, well, our degree is going to be 3. Our leading term is that negative 4x cubed. And leading coefficient is going to be negative 4. This next one is written in descending order, so our degree is 5. Our leading coefficient, our leading term, is going to be 5t to the 5th power, and our leading coefficient is also 5. Next one, I'd write this as negative p cubed plus 6p minus 2. And for that, our leading term is negative p cubed. Our degree is 3, and leading coefficient is negative 1. Now let's talk about the graphs of polynomial functions. And what you'll notice is that when we look at the leading term, that's going to give us the end behavior. And when I talk about end behavior, I'm talking about as x gets big or x gets small, what's happening to it. And to contrast that with what we're going to talk about in the next video, local behavior, which is stuff as x is small, as x is near 0. Excuse me. So we really look at that leading term. So for example, f of x equals 5x to the 4th plus 2x cubed minus x minus 4. 5x to the 4th is the leading term, and so that's the end behavior is going to match the power function like that. So since it's a positive leading coefficient and an even power, it's going to go up as x gets big or x gets small. In this next one, our leading term is a negative 2x to the 6th. So negative leading coefficient and even power. So given that it's negative leading coefficient, both sides are going to go down. If there's a positive leading coefficient, both sides go up. The next one, 3x to the 5th is our leading term. So positive leading coefficient, odd power. As x gets big, it goes up. As x gets small, it goes down. And I think this is our last one. Yeah. Our leading coefficient, our leading term is negative 6x cubed. So negative leading coefficient, odd power. As x gets big, it goes down. As x gets small, it goes up. So basically, it's following power functions for the end behavior. Now, the middle behavior is going to be a little different, and that is in the following video. So describe the end behavior and determine a possible degree of the polynomial. So for this one, as x gets big, f of x will go to infinity. And as x gets small, f of x goes to negative infinity. So this looks like it's got a positive leading coefficient, and n is odd. And I'd almost say this is basically looks like a not knowing the degree. I'm going to say degree 3. But it could be a 5. But most likely, I mean, it looks like a 3, just the shape of it. Crosses 3 times. And it looks like a pretty smooth curve. No funny things are happening there. It's not getting bunched up any places. Or there's no like coming up like this, you know, where it crosses, but maybe misses on one of them. So I'd say it's a degree 3. Given the function f of x equals negative 3x squared times x minus 1 times x plus 4, express the function as a polynomial in general form and determine the leading term, degree, and end behavior. So I'm going to look at this as negative 3x squared times, I'm going to FOIL that out, and that's going to be x squared plus 4x minus x minus 4. So negative 3x squared times x squared plus 3x minus 4. And I'll distribute this negative 3x squared through. So it's negative 3x to the 4th minus 9x cubed plus 12x squared. So our leading term is going to be negative 3x to the 4th. Our degree is 4. And the end behavior, given that it's a negative leading term, negative leading coefficient, and even power, as x goes to infinity, f of x will go to negative infinity. And as x goes to negative infinity, f of x will still go to negative infinity. So both sides are going to go down. It's going to be going down and down. Like it's going to cross at negative 4, and it's going to cross at 0, a touch at 0, and cross at 1. So it's really going to be like that. I mean, we weren't asked to draw, but something very roughly like that. Okay, in our next video, we'll talk about identifying local behavior of polynomial functions.